All right, I got to cheat you out of the music, but I wanted to just show you. This is one of the first ones that's printed, the new fields, new shapes. It, my goodness, I'm seeing double for some reason. Wow, that's weird. What's going on here? It's not my camera, it's my eyeballs. Anyway, what we've got here is a test mule that I have. This one happens to have ball bearings in the front axle and in the back, not axle, but the front shaft and the rear shaft ball bearings. So, you know, it's very smooth rolling, right? What I'm looking for here is interference or clearances on the sides of the where the magnets are, to make sure the new part doesn't have anything hanging in the way of plastic. And I cannot tell you how smooth this rotation is. It is very smooth. And the magnetism, as you can see, is there. It will grab it and pull it in one way or another. It'll hold it there, like here, see? It's being held, kind of, comes back. To overcome that, we energize the armature, and then it starts to spin around against the fields of the permanent magnet. The one thing that I've changed that I'm hoping will make a performance difference is the orientation of these magnets. When I first built this thing, I had a lot of problem with the bolt interference, and I found one way it was somehow I could rotate this assembly and I got a little more clearance for the bolts to go through. Not sure why that worked, but it did at the time, okay? But what I've found was this one end here has no capture. You see how this comes up, this comes up, this comes up. There's no capture here. So I tried to push that up into that space and bring this end around, sort of rotate it. And that seems to have helped in the way of capture, because now we got equal capture on all four sides. And what I needed to make sure was that I didn't create any interference in the rotation as I did that. And I am very thrilled to say I see this as a very good win. The fact that it can just bounce back like that, very free motion. Now, of course, the ball bearings gives it a little extra, but I'm feeling very good about this. This may mean that what I use on the back sides of these are an additional rectangle magnet down here, and that gives this inner force a lot more capability, so that well, like here, I don't know if I can't really explain it to you, but this force with just the arc magnet alone, it's a very strong magnet, but it's not as strong as one with the rectangular magnets. A lot stronger. And sometimes I may be overpowering the armature in doing that. And I did put some very large magnets in the motor I sent out to Don to evaluate, and Don is the guy that melted down the field. So I'm thinking, okay, I'm going to go back to the smaller magnet and make sure I have the clearances, make sure the orientation of the arc is rotated as square as I can get it. And I'm using a tougher material. It's still PLA, but it's called PLA Plus. And in this version, the company names it Pro PLA Plus, whatever. But it's good to 90 degrees, and then I'm going to centigrade, and then I'm going to anneal it, which means I'm going to warm it up to about 100 degrees for 20 minutes and just let it cook. And what happens are the molecules inside the plastic bond a little tighter, and they can withstand temperature change better. And with the annealing, it'll get up to 120, and 120 is where we are with the smoke. But certainly 120 would support this operation as well, which I think is pretty reasonable. I also think we may have run into a friction problem with the other engine, the one Don had, because I had the old style plastic part that sort of stuck in more and was out of balance.